Hello, everyone. Welcome to our 10:30 a.m. session, and we'll be talking about distraction to augmentation with Dr. Pattie Maes, who is a professor in MIT's program in Media Arts and Sciences and runs the Media Lab's Fluid Interfaces Research Group. Welcome, Dr. Maes, and thank you for joining us.
Thank you for having me. Good morning or good afternoon, everyone. It has only been 13 or 14 years since the first smartphones were introduced. And of course, since then, the devices have become completely ubiquitous and we are inseparable from them. They offer, or they put the world's information at our fingertips, but a lot of people would argue that they are not necessarily a net positive in terms of improving our performance and well-being. Study after study is emerging showing that smartphones have negative effects on things like memory and our ability to recall things that we read, for example, our ability to solve problems, to be creative, to relate to other people. In addition to all these negative impacts on our performance, they of course are also negatively impacting our mental well-being, our physical well-being, and our social well-being. So the question that I ask in my group is, can we design devices that enhance our cognition and help us thrive? Can wearable or mobile devices support functions that are critical to being successful in life? Can they, for example, help us with memory, with being attentive, with being creative, with making the right decisions, with communicating more effectively, with being motivated or having grit, with having self-awareness and being able to be in control of our own emotions? So we try to really extend what devices do for us and go beyond just providing information and helping people with these extremely critical skills that are needed to be successful in life. Our approach is one where we take some insight from psychology or neuroscience, and that then inspires a new wearable device or a new mobile device that can monitor some aspects of a person's cognition and also support or enhance that aspect of cognition in the wild, in real life. That then enables new studies, new opportunities for studying how people respond, especially when they are augmented with devices that help them with these cognitive functions. And that then, again, in turn, can lead to new insights in psychology and neuroscience. Let me give you an example. And in fact, I'll give you a range of examples from the work in my research group. Let's start with memory. A couple of years ago, we used an augmented reality headset to help a person memorize a set of facts by relating those facts to their spatial memory of a space or an environment that they know well. Of course, some of you may have heard of the memory palace, which is a well-known technique used by memory experts, for example, to memorize facts by relating them to an imagined space or palace in their minds. So we actually made it easier for people to use this technique to memorize a set of facts. And the set of facts that we chose was the winners, the consecutive winners of the Super Bowl. So we made people memorize the winners of the Super Bowl, a pretty random set of facts, but we helped them to do so by using this augmented reality headset while they were walking from the subway station at MIT, Kendall Square Station, towards their office at MIT, for example, in the Media Lab building. So as they were getting out of the train at the T station, they started seeing virtual images superimposed on their real environment, their real visual environment, that would help them remember which teams won the Super Bowl in all these consecutive years. So as you come out of the train, you see a guy with boxes, which represents the Green Bay Packers. Then again, you go up the escalator, another guy with boxes. Then you come out of the subway, and right there in Kendall Square, there's a jet parked, or a virtual jet added to your visual scenery to, of course, remind you that the New York Jets were the next winner of the Super Bowl. As you go to the medical building, you see an Indian sitting on the steps because the Kansas City Chiefs won the next year, and so on and so on. Here's a little video of a person actually using the system. The Miami Dolphins are being shown while she's riding the elevator, or she may see a panther appear in the lobby of the new Media Lab building, and so on. And because we have very good spatial memory, especially of an environment that we know very well, like the path from the subway to our office at the Media Lab, we can actually recall very easily what all those odd pictures were that we saw as we traverse basically that path from the subway station to our office. So we actually did a test, and we gave people all these teams to learn using our Nevermind system. And another group basically used paper to learn the consecutive winners of the Super Bowl. Right after they both had this learning experience, they performed at about the same level, almost perfectly. But already 24 hours later, the people who studied this set of facts on paper had forgotten more than half of the answers or the facts. And again, that dropped off even more so after 7 days, while the group that used the augmented reality system actually maintained its performance and was able to recall all the subsequent winners just by, in their mind or mentally, traversing this path and remembering what all the pictures were that they saw. So this is just one example of how we try to help people with cognitive functions using wearable devices, using sensor technology, using AI technology. Let me show you another example. Being attentive is, of course, especially hard these days, especially now that everything is happening via Zoom. We built a set of glasses that have built-in EEG sensors and EOG. EEG, of course, measures brainwave activity, and EOG measures eye gaze. And these glasses are totally self-contained. They can wirelessly stream data or record the data, and you can download it later. And using this EOG and EEG data, we can actually measure whether a person is being attentive to an external speaker. And there's even more issues that we can fairly robustly measure. For example, whether someone is more visually attentive in the moment or listening more to the audio, which voice they are listening to, if there's two competing voices, and so on. And we used this set of glasses, we call them Attentive U, in a classroom setting. So we had 1/3 of a group of people, or we actually had an entire group listen to a lecturer, give 3 one-hour lectures, and 1/3 of the group of people used the glasses with biofeedback. So that every time their attention dropped and they started getting distracted and were no longer listening to the speaker, the system would actually give them a sound, or would play a sound in their ear, so that they would be reminded or nudged to pay attention again. A second group a second third of the people got random feedback, random audio feedback at different times. And then a third group got no feedback at all. We had them listen to lectures about neural networks, for example, and then gave them a quiz afterwards to see how much of the material they had retained. And you see here in blue on the right, you see the people with biofeedback who were nudged to pay attention again every time their attention waned. They actually did best on the test or the quiz of the material. The random group that got random reminders to pay attention did second best in gray, and then the third group that got no feedback at all performed the worst. Of course, we would never want to impose the use of these glasses on students or on workers and so on. We see these more as a new type of wearable that a person could choose to put on when they want to be attentive, when they really prefer to pay attention and not mind wander in a certain situation. We've also used those same glasses in a simulator of a car and had people drive for an hour in a real car simulator donated to us by one of our member companies. And we showed how these glasses can be used also to tell people when they are fatigued and either remind them to be attentive or better, remind them to maybe take a break and stretch their legs. Creativity is another area that we've worked on. Of course, creativity is also increasingly important as a 21st century skill for people. And many artists and scientists over the years have used interesting methods to support themselves in being creative. There is a technique sometimes referred to as the steel ball technique that was used extensively by people like Edison, Tesla, Salvador Dali. Numerous artists and scientists used this technique where they would basically take a nap with a heavy object in their hand. In fact, Thomas Edison in this sculpture is even portrayed in his sculpture with that steel ball in his hand. So the scientist or artist would fall asleep or take a nap with that steel ball in their hand and force themselves to think about a particular issue as they fall asleep, as they take a nap. And then, of course, when they enter stage 1 of sleep, their muscles relax and they drop the object, and as a result wake up, and then they quickly would try to write down what weird dreams they were having at that time to give them inspiration for maybe some project that they were working on. So the painting on the left, actually, Dali credited with or presumably came up with that painting based on a dream that he had. We have built a system that makes it possible for everyone to use this technique and even an improved version of the technique to basically help themselves dream and be creative during their dreams related to a theme or a project that they're working on. So hypnagogia is actually a stage of sleep that is really at the onset of sleep. It's when you're just falling asleep, and it's actually fairly similar to REM sleep in that people have very vivid dreams in hypnagogia, in this phase of sleep. So we built a system where which consists of a sensor glove as well as an app. And the app, you use the app to record a prompt that will be played at the right moment when you are falling asleep to both encourage you to dream about a particular theme or a particular prompt, and also later to recall or to record your dream, the dream that you had just now. So we with the sensor glove, we detect what stage of sleep you are in using the muscle flexon sensor, beats, the heartbeat, and the electrodermal activity sensing. And the system basically, you first use it to record a dream prompt, something you want to dream about, and then you take your nap, and the system will play you the dream prompt, remind you or to dream about a particular thing as you drift off. And then at the right moment, when you've had a short dream in hypnagogia, it will wake you up and ask you to recall or to recount your dream. And then it lets you drift off again, prompting you to dream about the theme that you want to dream about. And you can actually repeat this process multiple times to record multiple dreams. We just published our study of this device. We had 48 subjects that were again divided in different groups. And what we showed in this study, which you can find in the journal Consciousness and Cognition, is that people do indeed, and you see it in purple here, dream. 75% of the people that get these prompts to dream about a particular theme, and our theme of choice was just a tree. So we reminded people to dream about trees. So 75% of the dream reports included trees and references to branches and so on. And we also had people write stories and do other tasks related to the concept of a tree right after they woke up. And the group that used our dream incubation device actually did best on the creativity tests that we gave them right after the experiment. Decision-making is another area that we work on. Just recently, we have been building a wearable, or we have been using a wearable audio device, audio input-output device, to help a person make decisions related to statements that they hear. So all of us, of course, especially these days, are hearing a lot of statements being made by politicians, advertisements in business meetings, and so on. And people can use help in being more mindful about whether to trust these statements or not, or sort of thinking about these statements and whether they may be true or false. So we built a system that listens to statements that a person also hears. It's like a second brain almost that is also listening to the statements that you listen to. And it classifies these statements as being supported or not supported, and on what basis. Like, is a statement supported by a study? Is a statement supported by an expert having made that statement? Or is there no support at all? And the system will actually help the person decide what to do with the statement they hear. It can either just tell them this statement is supported or not, or it can also actually, in another version, give an explanation or act as a system that can provide an explanation, and it will say this statement is supported and here's the reason why. So we again did an experiment with a whole range of subjects. They were listening to fairly political statements that were spoken to them. The device also listens to the statement. It classifies the statement and decides whether it's supported or not and why. And we basically looked at when the system then gives its feedback to this user and says, this statement is supported, or this statement is supported and here's why. We looked at agreement, whether the subject agrees with the statement. We looked at reasonableness, whether the subject thinks that the statement is reasonable. And we also asked the subject whether they would donate money to an organization that supports this statement. And especially for the first two, so agreement with the statement as well as reasonableness, the fact that the system had or that the user got advice from the AI in real time with an explanation, there was a significant difference there in the person then adopting or believing those statements and thinking that they were reasonable. And there was also an increase in the person be willing to donate more money, although that was not statistically significant in our small sample that we tested. We are also working on communication and how systems can help people in real time with communication. We have a bracelet that we designed called the Project Us, that actually gives insight into how a person you are talking with is reacting emotionally to what you are saying. This could be useful in workplaces, for doctor-patient relationships, and of course for couples therapy. So we give the person feedback about the conversation partner's electrodermal activity, and we give you haptic feedback or vibration if the other person is reacting strongly to a statement that you make. We tested this with 9 couples, and we showed in our paper that was published just recently that people who received feedback and knew when the other party was reacting strongly, that they actually changed the way they talked subsequently and used more words like, why do you feel like this, and explain to me, etc. So the system really helped people with self-awareness of how their words affect the other, and it helps them modify their own language and be more aware and more mindful of how they were speaking with their partner. So I want to summarize by saying that I think that today's solutions for self-development and self-improvement are far from perfect. You can read books that tell you how to become a better communicator. You can talk to a therapist, follow a guru. You can even take pills that can help you be more attentive and things like that. But I think that there is a real opportunity for new wearable devices that can be cheap, that can be ubiquitous, just like smartphones are today. New wearable devices can help us grow and thrive. They use sensor data about the person and AI techniques to basically process that data, and can provide real-time support to help a person with important cognitive skills such as attention, creativity, memory, communication, and more. I just want to conclude by saying that we think that it is important to be very mindful of the ethical sort of consequences of these types of technologies. And so we have certain design principles that we use where we want to enable people and never enforce them to use these augmentation techniques. We design our systems together with the target users, and our aim is always to teach people certain skills rather than make them dependent on these new devices, and last but not least, to keep the data private and local. I'll end there. This is our information in case you have follow-up questions that we may not get to right now. Thank you.
Thank you so much, Pattie. That was an absolutely fascinating presentation. We've got time for, a question or two. So I'll read off a question that I think is a nice summary of what you discussed. So one question is, how do you ensure that bias isn't built into these responses? These comments or inputs that you're getting from these listening systems and analyzing in order to create or to enhance and augment our lives. How do you make sure that that is correctly interpreted?
Yes, very important question. I'm old enough that I grew up thinking or in a world where we were paying for computer services and paying for software and so on that would help us, say, be more productive and so on. But unfortunately, we are now using only using this advertising model where basically software is free and services are free, but, or at least they seem free, but there is, of course, a big catch because they may be biased or there's always another incentive at play. So I think it is very important that we go back to putting the user central and that we build systems where ultimately the incentives of the software and the service that is offered are aligned with what the user wants rather than what, say, an advertiser wants or what, say, Facebook or Google wants and so on. So it's very important that again, these types of services will be introduced in a different way than in a way where there is a lot of control and potential bias being implemented because of commercial incentives.
Great. Thank you for that
Commercial or
response.
political, I should say.
Right, exactly. It's hard to disentangle those two these days.
Yes.
Well, Dr. Maes, thank you so much again.
Thank you for having me.
That was very enjoyable. And attendees, thank you so much for your insightful questions. I see there's a lot of great discussion going on. Unfortunately, we have to move on to our next talk, but feel free again to continue discussion via our MIT CNC Slack channel. And if you'll be joining our next talk, please go ahead and follow the link and we'll get started in 5 minutes at 11 a.m. Thank
Great.
you all.
Thank you so much.